So in this example, we're going to use Pythagorean theorem again, but we're not going to use it. We actually need to make sure we're identifying the correct side first. So you can see in this example, it's quite different because we already know what the hypotenuse is. And that's why I kind of really made a point of talking about that earlier in the lesson, because if we don't recognize that, hey, this is the hypotenuse, then the mistake we're going to make is we're going to go ahead and go, oh, 8 squared plus 16 squared equals c squared. And we're definitely going to be wrong because the c squared, we know our c. Our c is 16. So a lot of times students get very just kind of wrapped up in doing the same thing over and over again, and they just plug into the a and b every time. You've got to be more careful on that. This is our c, right? We know that this is c. So sometimes it's really helpful to write that c equals right next to it. The 8, that doesn't really matter who you call this, but I'm just going to call it a. Right, so if we're going to set this up, it's going to be 8 squared plus, we don't know the b, aka x. I'll use x this time. So we don't know the b value. We don't know the other leg. So x squared equals 16 squared. So again, we're now going to do the same process. We still need to solve for our missing variable, but you've got to be careful because the next error that students make is they then try to solve this just by maybe adding the 8 squared and the 16 squared together. You can't. You have to think about, well, what these values actually are. So there's two ways to go about doing this, and one way is a little bit faster than the other, but if you don't feel confident, you can kind of use the other way. The longer way is really to actually write down what these variables actually are, right? So if we square 8, we get 64. So 64 squared, oh, excuse me, not squared anymore. So 64 plus x squared equals, if we square 16, we get 256, right? And then from there, just like any equation that we have to solve, we would subtract the 64 over. Okay, so we would need to subtract the 64 over. And I went ahead and pulled up Desmos here so that we can do that off to the side. So all we have to do here is type in 256 minus 64. And so we're left with the 192. So x squared equals 192. Now, I'm going to show you kind of how we could have done that in a slightly different way that would just save us the time of figuring out what 8 squared and 16 squared are. So you may not have known this off the top of your head. You could have just subtracted over, so starting from the beginning again, 8 squared plus x squared equals 16 squared. We could have subtracted them over in their squared format. The only time that this is dangerous, and hear me carefully, is you do not do 16 minus 8 here. You cannot do 16 minus 8. You have to leave it as 16 squared minus 8 squared. And then that would be what you would type into Desmos. You'll see that we get the same thing. 16 squared minus the 8 squared. So if you just are typing things into Desmos and would prefer to just type that in, you'll get the same answer, right? But be very, very careful not to do 16 minus 8 and then square that. That isn't, you're not following order of operations, which is why that would backfire on you. Long story short, we now have this expression, but we're not done because we need to take the square root of both sides. So if we take the square root of both sides, doesn't matter which of these we work with, but if we take the square root of both sides here, we're going to be left with x squared, but not x squared, just x, equals square root of 192. So let's come back over here. Remember to do square root on Desmos. All we do is type SQRT. It turns into that. And we can now type in square root of 192. So you'll notice that we don't get an exact answer. We're going to get an approximate answer in this case, 13.856, so on and so forth. We'll just round that 5. That 5 rounds up, so 13.9 is our approximate answer for the length of x in this example. So hopefully that makes sense when you're trying to find the length of a missing side. versus the length of that hypotenuse.